Hi there, this one is help with 7.1, just part A on this. I've had a request on doing a video to help with defining rational expressions. And basically what that means is just making sure that whatever you're working with here, that eventually what we're going to get to is solving and figuring out what x equals. But to do that we have to make sure that whatever x equals, it doesn't create an issue in the problem. And one of the things we have to worry about with fractions always is that your denominator does not equal 0. And so as we get started in this chapter, they kind of want to make sure that you understand denominators will never be 0. So what we have to do on each one of these is just look and say, okay, what would make the denominator be 0? And so I take this right here and I make sure that whatever happens, that doesn't end up being 0. So sometimes you can just look at it in your head, but other times maybe it helps you to set up a little equation. And what I do is I kind of set up a not equation, because I want to make sure that that does not equal 0. And then I just solve it. I'm going to subtract my 1. So 5x does not equal negative 1. Divide by 5. So then, in this particular problem, x cannot be negative 1/5. That would create a problem if I plugged in negative 1/5 for x right here. That would become a negative 1 plus 1 is 0. And that's an issue. Don't want that to happen. So all we're doing on this is finding out what x cannot be. Notice I'm doing nothing with the numerator. Don't care at all about the numerator. It can be whatever I want. Alright, so looking at this one, ignore the numerator, just look at the denominator. Alright, so I'm going to solve this one. 3x minus 3 cannot be 0. Add the 3. Divide by the 3. So x cannot be 1. Okay, it does get a little wormier. Looking at this one right here, I've got this x squared business going on. And so what you have to do on this one is factor. This kind of comes back from last chapter when we had to factor. So I'm going to have x and x, factors of 12. That'll end up with a difference of a 1 here, so I'm going to try a 3 and a 4. I'm going to want to have a negative 4 and a positive 3 so that I end up with a negative x on my inner and my outer. And so then when I look at this, I can say, all right, so I don't want my x plus 3 to be 0, but I also don't want the x minus 4 part to be 0. So I don't want x to be, in this first quantity, I wouldn't want it to be a negative 3 because that's going to create a 0. And I don't want it to be 4 in the second quantity. That would create a 0, which would ultimately make my denominator be 0. So if you have some sort of a quadratic down here, you have to factor it and pick out what those restrictions will be. Let's try this last one again. I'm going to have to factor. This is a little bit different. I'm going to pull out a GCF on this one. Pull out a 3x. Then I have a 3x minus 1. And then I'm going to set each of these not equal to 0. I don't want 3x to equal 0. But I also don't want 3x minus 1 to be 0. Now on this previous example, I didn't really set this all up because sometimes you can just look at it, you know, as you get better and better at this, you can look at a quantity and tell what's going to make that be 0. Sometimes it's a little trickier, like on this one when you have this coefficient here, so maybe I go ahead and set it up. So on this one, I don't want 3x to be 1, divide by the 3, x cannot be 1/3. But over here, this also is a problem. If I divide by 3, 0 divided by 3 is 0, so I also don't want x to be 0. So this one has 2 restrictions as well. If you're questioning whether it's right or not, you can always plug it back in. If I plug 0 in, that's going to be 0 minus 0, which ends up being 0. Or if I put in my 1/3, I can check that also. But in the end, you just don't want the denominator to be 0. Don't care about the numerator. Make sure the denominator does not equal 0. Good luck.